Today I am going to discuss question number 21 to question number 25. Now what's the question? देखो, question number 21. A balloon is made of a material of surface tension S and inflation outlet from where gas is filled in it. Has small area capital A. It is filled with a gas of density rho and takes a spherical shape of radius capital R. तो देखो, this is a balloon and this is a small hole of cross-sectional area capital A. A gas of density rho is filled in it through the hole, and after filling the gas, the radius of the balloon becomes capital R. Then when the gas is allowed to flow freely out of it, its radius small r changes from capital R to 0 in time t. Now the gas inside the balloon is allowed to come out through the hole. And total time taken is capital T. If the speed small v of the gas coming out of the balloon depends on small r as small r a power capital small a. So देखो, the gas inside the balloon is coming out through the hole, and at any instant t, the emerging velocity of the gas through the hole depends on the radius of the balloon as v varies as small r to the power a. Now we have to determine an equation of emerging velocity of the gas. To determine the velocity, we consider 2 points, one just inside the hole and another just outside the hole, and we apply here Bernoulli's theorem for horizontal flow of fluid. Now, what is the Bernoulli's theorem for horizontal flow of fluid? Summation of pressure energy and kinetic energy is constant. Suppose atmospheric pressure is PA. Atmospheric pressure is PA. So the pressure at that point is PA plus excess pressure. Here, the velocity of the gas is 0. So, kinetic energy per unit volume of the gas equal to 0. Now, the outside point. For the case of outside point, pressure is atmospheric pressure. And if emerging velocity of the gas is small v, then kinetic energy per unit volume is half rho v square. Okay, now cancel PA, half rho v square equal to 2s by r or v square equal to 4s by rho r, or v equal to 2 root s by rho 1 by r to the power half, or v equal to 2 s by rho r to the power minus half. From this equation, we can say v varies as r to the power minus half. Okay, so a equal to minus half. तो देखो v depends on the instantaneous radius of the balloon as v varies as r to the power minus half. Now we have to find a relation of capital T on S, capital A, rho and capital R. The gas is coming out through the hole. Suppose at any instant of time t, the radius of the balloon is small r, then the volume of the gas V equal to 4 by 3 pi r cube. Now we differentiate this equation with respect to time. Now dv dt equal to 4 by 3 pi 3 r square dr dt, or dv dt equal to 4 pi r square dr dt. Equation number 1. What is dv dt? Rate of change of volume of the gas inside the balloon with respect to time. We know that gas is coming out through the hole. Okay. Now small v is the velocity of the emerging gas. So volume of the gas emerging through the hole per unit time, that is A into V. Again, I repeat again. Volume of the gas coming out through the hole per unit time, that is capital A into small v, which is equal to dv dt minus 4 pi r square dr dt. Here we introduce a negative sign. Why? The radius of the balloon is decreasing with respect to time. Due to this reason, we introduce here a negative sign. Okay. देखो, और 4 pi r square dr dt equal to a देखो, और माइनस साइन a into small v From here we put the value of small v to root s by rho 1 by r to the power half. Now multiply r square into r to the power half becomes r to the power 5 by 2 dr equal to here 2, here 4. After cancelling becomes minus a by 2 pi. Okay. Root over s by rho dt. Now we integrate this equation. Okay. When time start, radius of the balloon is capital R, and after time t, after time capital T, radius becomes 0. Radius becomes 0. Okay. Or after integrating r to the power 7 by 2 by 7 by 2, that means 2 by 7. For this negative sign, we can change the limit of the integration 0 to r equal to a by 2 pi root over s by rho t 0 to capital T. Okay. Now 2 by 7 capital R to the power 7 by 2 a by 2 pi root s by rho into capital T. Okay. अब देखो और capital T equal to 4 pi by 7 2 pi into 2 4 pi by 7 here s to the power half, that becomes s to the power minus half. Okay. Here a, what is the power of a? 1. Now it becomes a to the power minus 1. Here rho a power half becomes rho to the power half, and capital R to the power 7 by 2. अब देखो, the question is capital T varies as s to the power alpha. So alpha equal to minus half. Okay. Capital A to the power beta. So beta equal to minus 1. Rho to the power gamma. Gamma equal to half, and capital R to the power delta. Delta equal to 7 by 2. So what is the correct answer? Correct answer is number 4. Okay. अब देखो, in example we can solve this problem by dimensional analysis. तो देखो, here t varies as s to the power alpha, capital A to the power beta, rho to the power gamma capital R to the power delta, or capital T equal to a constant capital K. Capital K is a dimensionless constant. S to the power alpha, A to the power beta, rho to the power gamma, capital R to the power delta. Now, we equate the dimension on both sides. तो पहले देखो, dimension formula of time is capital T. Surface tension mt to the power minus 2 to the power alpha. Area L square to the power beta. Rho density m L to the power minus 3 to the power gamma. Radius L to the power delta. Okay. Now m to the power alpha plus gamma, L to the power 2 beta minus 3 gamma plus delta, T to the power minus 2 alpha. And left hand side we can write this as m to the power 0, L to the power 0, T. Now we can equate the power of capital T on both sides. Right hand side, power of capital T is minus 2 alpha. Left hand side 1, or alpha equal to minus half. तो देखो ये जो चार ऑप्शन है 1 और and 2, 1 and 2, what is the value of alpha? Half. 3 and 4, what is the value of alpha? Minus half. So we can cancel 1 and 2. So the answer would be question number 3 or 4. Now we determine another constant. Now we can equate the power of capital M on both sides. Right hand side alpha plus gamma, left hand side 0, or gamma equal to minus alpha, that is half. तो देखो option 3 and 4. In option 3, value of gamma is minus half, and option 4, value of gamma is half. So what is the correct answer? 4. Okay. Now question number 22. देखो a microscope has an objective of focal length 2 semi, eyepiece of focal length 4 semi, and the tube length of 40 semi. If the distance of distinct vision of eye is 25 semi, the magnification in the microscope is. So देखो, in this case, the magnification M of the microscope, normal formula, capital L D by F0 into Fe, where L is the length of the tube, which is given 40 semi. Capital D, distance of distinct vision of eye, that is 25 semi. F0, focal length of the objective, that is given 2 semi. FE. Focal length of the eyepiece, that is given 4 semi. 4, 10, 5, 125. So the magnification of the microscope comes out to be 125. Okay. अब देखो क्वेश्चन नंबर 23. Question number 23. Two identical point masses P and Q suspended from two separate massless springs of spring constant K1 and K2 respectively oscillate vertically. If their maximum speed are the same, the ratio capital AQ by capital AP of the amplitude AQ of mass capital Q to the amplitude AP of mass P is. तो देखो we know if a particle of mass m is hanging from a spring whose spring constant is k, then time period capital T equal to 2 pi root over m by k, where omega equal to root over k by m. And if amplitude of oscillation is capital A, then maximum velocity equal to A omega. Now, in this situation, here given two springs. First one having force constant K1 and second one having spring constant K2. Okay. This mass is capital P. This mass is capital Q. Now, what is given? If their maximum speed are the same. Here we discuss the formula of maximum velocity is capital A omega. Now, maximum velocity in this case, first case, AP omega P. In the second case, what is the maximum velocity? AQ omega Q. Okay. That means AQ by AP equal to omega P by omega Q. अब देखो, what is the equation of omega? Omega equal to root over K by M. And both the cases, mass of P and Q are same. Okay. Omega P root over K1 by M by omega Q root over K2 by M. Cancel M. Root over K1 by K2. Now check the answer. Answer is, देखो, answer is number 1. Number 1 is the answer. Okay. देखो, answer is number 1. Okay. Now question number 24. देखो, what is the question? A parallel plate capacitor made of circular plates is being charged such that the surface charge density on its plates is increasing at a constant rate with time. The magnetic field arising due to displacement current. Okay. देखो, this is a parallel plate capacitor whose two plates are circular. Okay. Two plates are circular. Now what is given? Given that surface charge density on its plates is increasing at a constant rate with time. Suppose sigma is the surface charge density, then d sigma dt equal to constant. Now what we have to find out? We have to find out the magnetic field arising due to displacement current. The displacement current ID equal to epsilon 0 d phi e dt. Phi represent electric flux and d phi e dt is the rate of change of electric flux with respect to time. Here electric flux equal to electric field into area. Electric field. Electric field means the electric field between the two plates of the capacitor, and A is the area. Now, the electric field between the two plates of the capacitor is sigma by epsilon 0 d dt sigma by epsilon 0. Take A by epsilon 0 out of the derivative. Epsilon 0 A by epsilon 0 d sigma dt. Cancel epsilon 0 A d sigma dt. Earlier we find that d sigma dt equal to constant. D sigma dt equal to constant. So displacement current is also constant. Now we join the periphery points of the two plates of the capacitor. It looks like a steady current carrying cylindrical wire. Steady current carrying cylindrical wire. We know that a constant current carrying straight long wire creates a magnetic field. Suppose this is a long constant current carrying conductor which creates a magnetic field. The variation of magnetic field from the axis of the wire is it increases from axis to the boundary of the wire, then decreases. Similarly, we explain the magnetic field creates by the displacement current. That is, magnetic field increases from axis to the periphery of the imaginary cylinder, and that is maximum at the periphery of the cylinder. Okay, now what is the correct answer? Correct answer is number 4. The magnetic field arising due to displacement current is non-zero everywhere with maximum at the imaginary cylindrical surface connecting peripheries of the plates. Okay. Now, question number 25. An electric dipole with dipole moment 5 into 10 to the power minus 6 coulomb meter is aligned with the direction of uniform electric field of magnitude 4 into 10 to the power 5 Newton per coulomb. The dipole is then rotated through an angle of 60 degree with respect to the electric field. The change in the potential energy of the dipole is. देखो, question number 25. पहले change in potential energy of the electric dipole. Suppose final potential energy is UF and initial potential energy is Uy. We know the potential energy of an electric dipole is minus Pe cos theta. चले minus Pe cos 60 degree minus initial potential energy minus Pe cos 0 degree. ताले minus Pe cos 60 degree equal to half plus Pe cos 0 degree equal to 1. That is Pe by 2. Here given electric dipole moment 5 into 10 to the power minus 6 coulomb meter, electric field 4 into 10 to the power 5 Newton per coulomb by 2. 5 into 4, 20 by 2, 10. 10 into 10 to the power 5 minus 10 to the power 6 into 10 to the power minus 6 comes out to be 1 joule. Okay, so the change of potential energy of the electric dipole is 1 joule. So what is the correct answer? The correct answer is number 3. So correct answer is 1 joule. You can solve this problem using this formula. What is the formula? the change in potential energy PE cos theta 1 minus cos theta 2. You can also solve this problem using this formula. Okay.